Okay, good morning, everyone. This is Jason. It's my honor to be here to share the SuperMap GIS 10i 2020 technology system to all of you. I'm the technical manager of SuperMap International, Asian, and Oceania Center. So today my topic will be the SuperMap GIS 10i 2020 technology system, and we call it as the BitDC, which is BIDDC. These 5 features is the main advantage of SuperMap GIS technology, and these 5 features make us different with. So what is BitDC? They are the big data GIS, the AI GIS, 3D GIS, and the distributed GIS and cross-platform GIS are the basic of all the system feature. Sorry, let me. Okay. And so today my topic will divide it into these 5 features, which is following the BitDC GIS technology, and I will show all of them to you one by one. The first one is the cross-platform GIS. The cross-platform GIS is very easy to understand, which means which means our GIS products, not only the server side, but also the desktop side, they can all run on both of Windows and Linux natively. And the second one is the distributed GIS. The distributed GIS mainly has these 5 technologies. They are the cloud native GIS, Edge GIS, and distributed spatial analysis and processing, distributed spatial data engine, and Geo-Blockchain. Actually, the distributed spatial analysis and processing and the distributed spatial data engine, they are all related to the big data technology, which is big data and GIS. The Geo-Blockchain is one of the new features we released in the latest version of our products, which integrates the blockchain technology to enhance the GIS capability. And the cloud native GIS and Edge GIS, these two are related to the cloud GIS. So the 2.1 is distributed spatial data engine, which is related to the big data GIS, as I mentioned. And here I list all of the SuperMap GIS distributed spatial data engine. They are such as the HDFS and the DFS. These two are the distributed file system. And for the SQL spatial database, we can also support the big data technology, which are the Oracle RAC, SQL Server Cluster, SQL Server Cluster, and PostgreSQL, and also others. So these SQL spatial databases are the advanced version of its own traditional version, such as the PostgreSQL, which is the advanced version of PostgreSQL. And this version of database can support the big data architecture. And for the NoSQL spatial database, we can support the HBase, MongoDB, and Elasticsearch. So we use all of those spatial data engine to cover all of the spatial data we have, including the vector data, the raster data, the image, the satellite image, even the 3D model data. And the 2.2 is the Geo-Blockchain. So first, what is blockchain? Blockchain is a spatial data storage method with following these 3 features. They are high security, traceability, and high credibility. So based on these 3 features of blockchain, we integrate the blockchain technology and GIS, so we get the result as Geo-Blockchain. So Geo-Blockchain is a high reliable distributed spatial data engine. Here I give you some demo. Suggest this is a food traceability demo. So we can based on the Geo-Blockchain to make sure every step, every progress of the food travel, food production can be traceable. So and also the data are reliable. And we can based on this data to show the whole trace of food on map using the GIS technology. And this one is the another demo, which is cadastral parcel tracking, because the cadastral registration is always the important business in the land resource management in all of the countries. So this kind of data must be traceable and they must be reliable. Otherwise, it will cause a lot of problems. So we can also use the blockchain technology on the cadastry applications. And also there are some other scenarios of Geo-Blockchain, such as in the area of planning management. It can be used in zoning and land use control, the real estate registration and transaction, and the natural resource asset and equity management. And on other management parts, it can be used in food and goods supervision and traceability, logistic tracking, and city management. All right, and the 2.3 is a distributed spatial analysis and processing. It's very easy to understand, which is the distributed spatial analysis and processing is to divide the single complex task into multiple tasks. Such as we have one server and we have some other server cooperate with it to be a cluster. So we can use all of the server to achieve one single task, and we can get the results as we can get the result in one server. So there are also some other some demos, such as this one is the distributed computing geoprocessing, which can be used in web and PC, and the whole process can be used in can be achieved in different machine. Okay, and 2.4 is about the cloud native GIS. The cloud native GIS is kind of the advanced version of cloud GIS. Cloud GIS is very easy to understand, which is we can use the server software to publish our spatial data and GIS capability to web as the services. But in the traditional mode of cloud GIS, all of the minimum unit is the server. I mean, on the cloud side is the server, and this server contains a lot of services. So in this method, it is kind of hard to do the operation and maintenance. Sometimes one of the server has problem, such as it crash or it broken. It always will affect the whole system. So the cloud native GIS can solve this problem perfectly, which is based on the microservice and containerization deployment. We can split the whole server into multiple independent service, and every service has its own container. Then we can and then we can combine the different container into different machine. So in this way, all of the services, they are independent. They won't affect each other, even some of the service crash. So the cloud native GIS is a fine-grained and high elasticity an independent and fault isolation system. So, and another one is the how to manage the thousands of service instances. If we have a lot of GIS service, so it will be always hard for us to do the operation and maintenance. In SuperMap, we provide the product which name is SuperMap Manager. It can integrate with one of the advanced technology which name is Kubernetes. And the integration between SuperMap Manager and the Kubernetes, we can achieve the features like load balancing, service self-healing, and elastic expansion. This is one example, such as about auto-scaling while widgets change, such as at first there is only 1 or 2 nodes, and if the widgets comes a lot, the concurrency rise a lot. So we can easily to add one node in this part to handle more widgets requests. And this one is showing the fault recover, such as when one of the node has problem, we can automatically remove it and use another node to replace it. Such as there is one case which is based on the cloud native GIS, the Geological big data system of Yunan. Yunan is one of the very big province in China. And in this system, they have 400 terabyte data and more than 400 service instances. So they use the cloud native architecture to handle all of those data and services. And then we go to the 2.5, which is HGIS. The HGIS is based on the edge computing technology to enhance the performance of GIS service when the end user has a long distance with the cloud center. We can deploy one edge computing server near to the user, like this, and the edge computing, the edge server can based on some proxy and the proxy and cache technology to enhance the performance of services. So here I summarized the 5 values of distributed GIS. They are high availability, high concurrency, high elasticity, and high performance, large capacity, and high reliability. And now we are going to the third topic which is the big data GIS. The big data GIS is kind of a very popular technology in recent years. I believe not only in China but all over the world. Of course, over overseas market they use this big data GIS already a lot. And the big data GIS divided into these 3 parts. I want to explain it from bottom to top. On the basic, the most bottom one, it is a spatial big data storage management. It shows us how to manage the big data, the spatial big data. And the second one is the analysis and processing. It shows us how to do the spatial analysis and how to do the data processing. And on the top side is the spatial big data visualization on different terminals, such as on website, such as on desktop side, even mobile side. Okay, so the 3.1 will be the spatial big data storage management. First, use some distributed big data spatial engine, and this is one of the case which is based on SuperMap and Alibaba, and each monitor the client location over the world. And we can see the total volume of the data is around 2.5 billion. And if we want to do the spatial analysis, we can easily draw bonds and get the results. And this is another case about the transportation information system of Chongqing, and it includes a lot of different types of data, such as population, road network, the traffic data, the railway data, the public transit data, and others. And so there are, and also the new data coming continuously. So there are 3 billion new data every month. And we're based on the big data technology to handle all of this data. Okay, and 3.2 is the spatial big data analysis and the processing. One of the keys is the COVID-19 big data system of Heilongjiang, and China government based on this kind of GIS system to control the situation of COVID-19. And we can see there are some functions like patient's history trajectory rebuild and patient activity district hotspot analysis. And the Princess poverty alleviation system of Gansu. It's kind of hard to understand, but easily speaking, it is to the national project to help the poor people in China. And based on this system, we can achieve the function of poverty population hotspot analysis and historical change analysis, and the poverty population distribution and education level analysis. Okay, the 3.3 is a spatial big data visualization, which are about the global flights distribution. We can use this kind of cool effect and moving effect to show the big data information on web and desktop. And this is another one, which is to show the real-time traffic visualization. We can see the whole system looks very cool and the effects looks very beautiful. And we have different methods to show different types of data, such as this one is use the 3D bar map based on the base map to show the hotspot of housing price changing. And okay, so that's all about the big data technology. And now we go to the fourth one, which is AI GIS. The AI GIS, the whole architecture or the system of AI GIS is very complex, but to summarize it, the AI GIS is based on the basic support, such as the data, the library, the framework. Then we can achieve three kinds of functions related to AI, such as they are the Geo AI and AI for GIS and GIS for AI. Okay, so the first one is the Geo AI, and this slide is showing all of the operator we can support about the Geo AI, such as classify analysis, the cluster analysis, regression analysis, and the 3D analysis, image analysis. So they are based on different types like spatial machine learning operator and spatial. So based on those operator, what we can do, first, we can do the object detection, such as this one is based on the satellite image data, and we can detect the palm tree. We can, because the palm tree is one of the important assets in some country, and this project is based in Indonesia. Indonesia, it has the most palm tree of the world. Then, based on the GeoAI technology, they can easily to detect the status of palm tree and get the counts, get the number of their trees. And also, we can achieve the land use data, land use classification, such as the left side is one satellite image data, and on the right side is the result of classification. Okay, and traffic prediction based on geographic neural network. So this system can do the prediction of traffic situation in 1/over advance. Okay, and the 4.3 is a GeoAI process tool. Based on the operator. Here I want to explain the processing of GeoAI. First, we need to prepare the data. So we call it is the data preparation. And based on the prepared data, we need to train the model to achieve the model construction. And then after we got the model, we need to, the third step is the model application. And in SuperMap, we support all of this whole process, from the model, from the training data preparation to the model construction, and to the model application. We can easily to achieve all of this. To achieve all of these functions without any coding. You can, based on the SuperMap Desktop X, to use the out-of-box functions and to achieve those technologies. Okay, and next, the 4.4 is AI for GIS, which means the AI capability helps GIS to enhance the GIS capability. Such as this one is based on the AR and AI. We just need to open our camera to walk around this area to pick some points on camera, and then we can collect this area, this polygon, and update it to map. And also suggest the data collection based on AI and AR, that is based on the camera, and the camera of our mobile phone can collect the point clouds of this model, and we can get to collect the data of this whole room. And another one is the AI and AR visual localization, which is based on the point cloud detection to locate our position indoor. And we all know that in the indoor environment, the GPS signal of mobile is poor. So when we want to get the high accuracy location of our mobile phone in indoor environment, we can, based on this kind of visual localization technology, to achieve it. And the AI and AR indoor navigation, this technology also can be achieved by a lot of map app. But in SuperMap, what we can do is we can achieve the indoor navigation based on your own data. You can create the road network by yourself, such as now I go to the Zara. Okay, and and also some AI and AR application for smart industrial park, such as we can use our camera point to a building to get the information of building, and we can use the camera point to a car and to get the information of this car, like when it comes, when and who it owns. Okay, and the last part of AI GIS is the GIS for AI, which is based on the GIS capability. And we use the GIS to show the results of AI technology, such as the spatial visualization for AI. And all of actually the results of analysis is based on the AI technology. And in GIS, we just show it on map. Such as we can see the CCTV video, it can detect every car through the camera, and we can point the car on map and to get the detailed information of every car based on the GIS system. And also, even we can achieve the GIS spatial analysis based on the AI detection, such as we can say this polygon is the busway, only bus can go through it. So we can detect the illegal occupied by the thing by the normal car, by the personal car. Okay, so that's all about AI GIS. And the last topic of my presentation is the 3D GIS. About the 3D GIS, what I want to say is the SuperMap 3D GIS technology is the most advanced 3D GIS over the world. We have confidence to say that SuperMap 3D GIS is the best 3D GIS over the world. So let's take a look. Okay, so the 5.1 is a 2D and 3D integration model. Here we list the types of spatial models. They can divide it into objects model, network model, and the field model. And in the field model, it has a 2D field model, 3D field model, and in the 3D field model, we have one unique advantage, which is the TIM and voxel grid. So based on it, we can achieve to show the underground geological body like this, and we can easily to dig the hole based on the geo body. We can call it geo body directly to get the detailed information of underground. And we can, based on the voxel grid, to do the simulation of sunlight hours. Yeah, we can use this to analyze the sunlight in the urban planning. And the simulation of communication signal. This is used. This can be used in telecom industry. And the 2D and 3D integration analysis, which is based on this kind of data, we can achieve the 3D spatial analysis based on the GPU, such as the skyline analysis. We can extract the line between the sky and the model, and we can switch the indoor and outdoor model, and also we can do the visibility analysis to analyze, like, from the viewpoint to the target point, whether I can see it or not. And all of the 3D spatial analysis are based on the GPU, which can enhance the performance a lot. And also the 3D spatial relationship judgment can be achieved. That means in SuperMap, all the models, they are real 3D. It's different with a lot of 3D model. suggests it looks like it is a 3D model, but actually it only has a interface. It's only a 2D polygon in 3D scene. But in SuperMap, we can do the we can based on the voxel grid to do the spatial analysis. It suggests this is based on the road to dig a hole to through the mountain. And also, like the real-time viewshed analysis, suggests this one is a viewshed analysis based on GPU, and we can simulate the viewshed of one of the CCTV camera. And in the new version of a 3D spatial analysis function, we can based on the viewshed to do the spatial query and get all the attributes and information for the content objects. And the multi-source 3D data integration is very important. So in SuperMap 3D GIS, we can achieve all of the 3D model data. 3D model, such as the terrain data, the oblique photography model, the beam model, and the field data, the pipeline, point cloud, water body, fine model, and the geological body. So, such as the oblique photography model, we can integrate them into a SuperMap platform, and we can do the object expression of oblique photography modeling, which is we can click one of the building to get the information of it, and this is to show the oblique photography modeling and the dynamic separation oblique photo modeling. And another important data source of 3D GIS is the BIM, which is building information modeling. And SuperMap can get the BIM data, can integrate the BIM data from different types of BIM software, such as Revit, Bentley, CATIA, and also others like Civil 3D and IFC and SketchUp. And we can integrate the BIM model with geologic body like this, and to show the detailed 3D information of this project. And point cloud is another important data, and we can this demo is showing to load 300 terabyte point cloud data. Okay, and the model data standard is one of the important achievements by SuperMap 3D GIS. That is, after we get the data from different sources, we can convert it into the common used 3D spatial data format, which is S3M. So based on the S3M, we can see all of those data can convert to S3M, and we can use the server application to publish it as 3D service. And on the on the terminal side, we can easily achieve the 3D model from the 3D service. Such as this is the highly efficient loading of large amount of oblique photography model based on S3M. It looks very beautiful, right? Okay, and the last part is the interaction and output. Besides of the data type, data engine, besides of the common used data formats, there we can also we can show the 3D scene, 3D GIS in different terminals, such as the WebGL, which is based on the web browser, and on the mobile side, and on VR and AR, we can all achieve them. Such as the AR, we can put the underground pipeline using the camera and to take a look at the pipeline directly through the camera of mobile. And the game engine is also one important advantage, which is we can output the 3D GIS, the 3D model format in S3M to the game engine, such as the Unity and Unreal 4, UE4. For example, this is the 3D visual effect of ocean and sky, and based on the game engine, we can achieve some beautiful effects on web browser. This is based on Google Chrome, and SuperMap also can support the game engine, like output data to game engine, such as this is a terrain data, and we can render the terrain data on Unreal UE. And and also this one is a 3D GIS data plus gaming experience. And all of these data are from the 3D GIS system. So we can get the gaming experience on game engine software. And also like this one, this is to do the profile analysis. And for the Unity, they are the same. We can also achieve the profile analysis and to load the GIS terrain, and also we can achieve the spatial analysis, such as to get the ISO line of the terrain and to render the terrain in different color based on its height. And also this is a virtual battlefield simulation. It is based on the GIS data, which is oblique photogrammetry, and the game spatial effect we just to make a demo like a tank battle. Okay, so as a summary, SuperMap GIS 10i 2020 technology system is mainly the BitDC, which is big data GIS, AI GIS, 3D GIS, and distributed GIS and cross-platform GIS. And this is the our product system of whole provided by SuperMap. They can be divided into three parts: the cloud side, the edge side, and terminal side. On the cloud side, we have SuperMap iServer as the server application to publish our spatial data and GIS capability. The SuperMap iPortal can easily help us to build or construct our GIS portal. And SuperMap iManager is mainly focused on the operation and maintenance. On the edge side, we have SuperMap iEdge, which can help us to enhance the performance when the network is not good. And on the terminal side, we have the terminal GIS for desktop. There are iDesktop apps and iDesktop. The terminal GIS for components, there are iObjects for different coding language, such as C++, Java, .NET, Python, and some based on some new technology, we have the iObjects for Spark, iObjects for blockchain, and the Scene SDK for game engine. And on the mobile side, we have iMobile, which is one SDK, and iTablet is an app. And the terminologies for web, we have iClient JavaScript and iClient 3D for WebGL. iClient JavaScript is mainly focused on 2D, and iClient 3D for WebGL is mainly focused on 3D. Okay, so that's all of my presentation. Thank you for listening.